No, sir, shall I start or shall I wait for the people to join? Now, where are the others? Okay. Yeah. Hello, Vishwanath. Uh, okay. Yeah, I'm going with the class today. Yeah, yesterday we discussed about this the standard deviation. In that, how to calculate the standard deviation. We have learned this, and um, we have seen how to calculate the standard deviation in a different ways, and we have seen the standard deviation using the assumed mean. There are two ways to calculate the standard deviation: calculating the actual mean, actual the mean of this and subtract the items from the mean and square it them, and you will get the standard deviation. And the next method is that we need to, we need to take the assumed mean as well. From that assumed mean, we need to get the values as well. Okay, and this is how we will calculate the standard deviation. Now, after calculating the standard deviation, we are trying to learn about the coefficient of the variation. That is standard deviation, divided by the mean into 100. This is how you'll get the coefficient of the variation. That's what we learned in the last class. Okay, what is variation? We already learned. The variation can be used to describe the square of the standard deviation by R. Okay, and efficient. Thus, variation is nothing but the square of the standard deviation. That is, variance is equal to standard deviation square is equal to variation. Or that then the relationship between the variance and the standard deviation is this. Variance is equal to square of the standard deviation, and standard deviation is equal to square root of the variance. Anything. If any value is given, we can consider from these two things. The lesser the variance, the lesser will be the variability of the series. All the formula used for SD in case of different types of series are used here without square root of the sign. Okay, we can see this illustration. Already we have seen yesterday this. And by correlation mean and the standard deviation, we need to calculate. If you take this example, compute mean, standard deviation, and variation for the following. You know that calculating the mean is easy. Frequency is 15. Mid value is 5, 15, 25, and this. And we need to calculate the Fs, F into X. If you multiply this, you'll get the Fx, and we'll get the D1 deviation. And if you multiply this F1, Fa into deviation 1, we'll get this. And Fd1 square, you will get these values. And sigma Fx divided by sigma F. Then you will get the mean value. And standard deviation is equal to, that this is the formula, square root of this and into y. Then you will get this variance. Variance formula is standard deviation square is equal to variance. Correlation mean and standard deviation we need to learn again here. These are the output of when we learn about the formula of the standard deviation, how to calculate the standard deviation by using the actual mean, and how to calculate the standard deviation by using the assumed mean. So before that, we have all these formulas. And from that, we will get the variance. Variance is what? Square of standard deviation. What is the symbol that we denote with the standard deviation?
Sigma, sir.
Sigma square is equal to the variance. Okay, sigma square is equal to variance. See, variance is equal to sigma square. Like in other words, sigma means standard deviation, SD square, standard deviation square. And if variance is given, if you want to calculate the standard deviation, if square goes to this other side, how it will happen? Like this. Sigma is equal to square root of variance. Right? I mean, square root of variance is equal to sigma. Sigma means standard deviation. Say by using these combinations, whatever the things comes under it, you need to by heart these formulas, and how to calculate also the steps are given here. And based on, drawing a table from this one, frequency is given, this one from that mid value take, Fx take, T1 take, and put it in the formula, we'll get the things. Next, correcting mean and standard deviation also can learn this. Merits and demerits of the standard deviation. Next, Lorentz curve. What is this? This curve was given by Dr. Maxwell Lorentz, a popular economic statistician. It is a graphical method to study dispersion. We are going into the another part now, study the dispersion. It helps in studying the variability in different components of distribution. Say, dispersion means what? Another word we used it. Dispersion, and another similar word is variation, right? That is what we are using. But we will use the word
variation, sir.
Thank you. Yeah. dispersion. It helps in studying the variability in different components of distribution. When the distribution went to the different components, we will understand that. And this Lorentz curve we need to understand. Generally, we won't use his name here and there, but we will use directly the curve in using that. But this was given by the Lorentz. And what is his name? Who given the SD, standard deviation? I told you in the beginning, right? Who gave that word? What is his name? You need to remember.
Carl Pearson, sir.
Thank you. Carl Pearson, right? Yeah, Carl Pearson and this one, Lorentz. Carl Pearson talks about the standard deviation. Again, I'm telling standard deviation can be calculated by taking the actual mean and assumed mean. By taking the assumed mean, we will get some value based on the type of data. You'll go with that. Right. Now, the curve is also used to study the distribution of profit, wages, turnover, etc. See, when we take these different kinds of variables, we can do that. This curve we used by him for the first time to measure the distribution of wealth and income. Okay, I think he used that curve for that particular purpose, and it can also used in just profits, wages, etc. Okay, study of the degree of inequality in the distribution of income and wealth between countries. This is very important. Why we use this? Already standard deviation is telling how much it is deviated from the actual mean, right? You tell me if more standard deviation is there, what is that meaning? More standard deviation is there. Say, let us say I have some values. Okay, let us say your marks. I'm using the same example from the beginning. All your marks. Okay, by calculating the mean average, what is the problem in calculating, sir? Why we are not satisfied with the calculating of the average? Why we are going again for the another method called standard deviation? Say, why we are talked about the range, standard deviation, all these things? Why we are not concluding, oh, mean is enough, no? Then why we are not going, why we didn't stop our thinking at that particular mean? Oh, average is giving, average value is representing the total items. But what is the problem?
Skewness, sir.
Yeah, the skewness, that is one thing.
Skewness.
The range is there, standard deviation. Because the point is that how much the average value is, how much the average value is, how far it is from the mean value. That is the thing. Okay. While drawing the Lorentz curve, the following procedure is adopted. See, this is standard deviation. The variables, values, and frequencies are both cumulated, right? Taking grand total of each as 100, percentages are obtained from those from these various cumulative values. On the x-axis, starting from 0 to 100 and take the percent of cumulative frequencies. On y-axis, start from 0 to 100 and take the percent of cumulative values of the variable. Next, draw the diagonal line joining. This is the origin point with a point 100, 100. The line origin point, OP, will make an angle of 45 degrees and y-axis is called the line of the equal distribution. Plot the points on graph and paper and join these points with a smooth freehand curve. The curves or lines will show the variability if they are drawn far from the line of the equal distribution. See this. Again, I'm repeating. See, the variables, values, and frequencies are both cumulated. The cumulative value, right? First value plus the remaining value, total. That's it. Taking grand total of each as 100, we will consider this as 100 percentage. Obtained from these various. On the x-axis, started from 0 to 100, take the percent of cumulative frequencies. See, for 100, how much is the percentage? On y-axis, 0 to 100, take the percent of cumulative values of the variable, already calculated in the first point. And draw a diagonal line joining 0, 0 and P100. Some diagonal line, you draw the line like this. A diagonal means like this, it will go from 0 to this. The line OP will make an angle of 45 degrees, right? If it is straight line, this is 90 degrees. When it is bent to the half, I think, are you able to see my the hand video? 90 degrees. When it is half,
yes, sir.
Yeah, when it is half, 45 degrees. 45 degrees. And the y-axis and is called as the line of equal distribution. Plot the points on the graph paper and join these points with a smooth freehand curve. So however the curve comes. The curves of lines will show the variability if they are drawn far from the line of equal distribution. See this line which we have drawn. If any point is far from this line, let us say this is the 45 degrees line. And if any line is far from this, we can tell this point is too far away from the, what is that, the mean value or the standard deviation, whatever. Then we will keep this value aside. Okay, this is the thing. Now, let us say, when we are calculating the average marks of a class, if one student having 1 mark, and if we are including that person also into this average marks, let us say some 90 marks or 45 marks, whatever, we are not able to, discriminate, right? In the sense like we are not able to find out the student. We are also calling, he is also called as the class group only. Others also who are having 90 marks, who are also having 45 marks, both are called as this average mark, but this is the problem. Okay, for that, to understand that, we will understand. This is about the skew. Now let's go into the skewness. The skewness refers to the lack of symmetry. A asymmetric distribution is called the skew distribution. What is symmetry means? Asymmetry. Symmetry, asymmetrical distribution. It's called the skew. We will see that. If the values of the mean mode are equal, then it is called the symmetrical distribution. But if the values of mean mode are not equal, then it is called the asymmetrical distribution. See, in the skewness, there are two things. Asymmetrical distribution, that is called the skew distribution. Simple. Skewness, it talks about what? The lack of symmetry in that, right? But if the values of mean are equal, then we call the asymmetrical distribution. As per Croxton and Cowden, these are the two names. Generally, yeah, those people CC. When a series is not asymmetrical, it is skewed. Symmetrical, it is called skewed. Not asymmetrical means asymmetrical, right? And in the words of Simpson and Kafka, measures of skewness tell us the direction and the extent of skewness. Again, what is skewness here? Refers to the lack of symmetry. And if more the symmetry is not there, that means the equality is not there, and it will call it as the very series not symmetrical is the skewness. More skewness is there. That's what we will tell. Measures of skewness tell us the direction and the extent of the skewness. This is what, when you measure the skewness, it will tell you how extent the skewness is. In symmetrical distribution, the arithmetic mean mode are identical. Remember this. The more the mean moves away from the mode, the larger the asymmetric and skewness. See, these lines, please underline in your textbooks while you are preparing. See, what we need to calculate for understanding the skewness, we need to calculate mean, median, and mode. Okay, remember that. If this in mean, mode, and median only, we will try to understand it. The more the mean moves away from the mode. Now, listen to this. Again, we know that what is mean means. Quickly tell, just for understanding the concept quickly. Come on.
Mean is nothing but average, sir.
Average, right? Average of all the values. Mode means what?
Maximum number of times a particular item has been repeated.
Yeah, simple words. Let's use that. Let us say how many are there now? 6 people are there. Okay. Sunita have 45 marks. That is out of 50. Sunita having 45. What are the other people's name? Abhiram having 45. Kanupa Reddy Sudha having 46. Sunita having 46. Vishwanath having 45. Somehow the mean is 45. Okay. And the mean is 45. And mode is also 45. See, the mean value is 45 means what? Average is 45, right? And mode is 45 means what? More number of people in the class got 45. Hello? Are you understanding what I'm trying to say?
Yes, sir. Yes, sir.
Yeah. If both are equal means what? Our average value is meeting the mode means it's a good thing, right? Because it is representing many people, right? Are you understanding what I'm trying to say?
Got it, sir. Yes.
Yeah, that is the thing. Now, if both are identical, the more the mean moves away from the mode, the larger the skewness is there. That means if more people are not having the average value, that means this is a skewness is there. Now we need to understand that. That means skewness is there means there is a variability.
Inequalities.
Skewness means the equality, and the larger the equality is there. Okay, right. Now let's try to understand. The normal curve is this. This is the normal curve, represent the perfectly symmetrical distribution, because mean average marks, let us say I'm taking the example what I taken, average marks is 45. Median means again the mid value is 45 and mode is also 45. Let us say both are equal. That means number of students out of 6 people having 45 marks, right? And the mean value is also 45. And median also, the mid value also out of 6 people, even the mid value also 45. Almost mid people we got. That means the normal curve represents the perfectly symmetrical distribution. Equal distribution is there. Nicely, we can use the data. It's a perfect data. Now, if that frequency, negative skewness, if the mean value, see this, mean and median values are going away left to that, this is called the negative direction. That means decreasing. This is called the negative skewness. Okay, negative skewed. Negatively skewed means in a negative way, equality is missing. Right? People are having 43, 44, and so on. Right? Your mode is people are having more 45s. That is mode. Right? Your mean value is, let us say, 35, but mode is 45, mean is 35, and it is going back negative. This is negative skewed. Yeah, are you understanding the concept? If you understand, it will be more clear. Right? Now, if the mean is going high, that is called positively skewed. Positively, what is called in a positive way, this is the asymmetric is missing. Symmetrical things are missing. Okay, right. Measures of skewness. Again, we have this in the skewness, Pearson coefficient of skewness, and Bowell's coefficient of skewness, Kelly's coefficient of skewness, based on, see, this is denoted with the letter J and SK. The formula is to calculate mean minus mode divided by SD. If mode is ill-defined, the formula to calculate SKP, Pearson coefficient of skewness, is 3. Is 3 into mean minus median divided by SK. Okay, please remember these formulas. You need to by heart it. Okay, and Bowell's coefficient. See, based on different combinations, we can also go into the deep and understand why he is subtracting mode minus me and dividing SD. If you understand the concept, what I said before, you will understand this, why this coefficient of the skewness is calculating. If mode is ill-defined, the formula to calculate SKP is 3 into mean minus median divided by SD. Why 3 came and this? If you go to how he came with the formula, you'll understand the concept. Boyle's also, he has taken the quartiles things and he given the formula. Okay. Now let's go into the understanding of the Pearson coefficient of skewness. This is very, very popular thing, Pearson's coefficient of skewness. Like let's say, compute Pearson's coefficient of skewness from the following data. Okay, let's understand this very, 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 very clearly. See, the basic thing, the first model I'm telling you so clearly, so that the advanced models, if you just put some efforts, you will be understanding very easy. Okay, let's go into that. Compute Pearson's coefficient of skewness from for. The mean we know how to calculate. Sum of this by number of things. See, sum of this is 250, 20 plus 25 this. And of course, when you are calculating mean, you no need to think about, keeping an ascending and descending order. You add this sum of them divided by number of things, you will get this 25. Mode is, which one is frequently this? Say 20 is frequency. How many is there? 120. I think 2 is there. This 2 is not the answer. Which one is repeated? That is the answer. Mode. This number represented twice in the series only. That is why mode. Calculate the standard deviation. Very easy to calculation from the arithmetic mean. First standard deviation. Always please remember that variability you need to check. I mean, these are the variables. Take the variables. Calculate the mean. Mean already we know that 25. how now the next one, small x, you need to calculate how each value is, differ from the mean in understanding x minus mean. X mean is the already calculated the mean value. X minus mean 25, 250, 25. So this is the total, and 250 divided by 10, 25 by n, 25. 25 minus 20 minus 25, like this you will get. Square it. Now, what is the formula for a standard deviation? Square root of x square divided by mean. This is the 12 approximately. Hello? Now, this is, we are not going for the, how this is what model I used here, calculating the SD. There are two models in calculating SD. What are the two models? By using actual mean. Another one. By using. Hello, is my voice clear, ma, to everybody? Hello. Yes, no.
Can you repeat the question?
Yeah. What are the two ways to calculate SD? Two models. I mean, two types. Okay, I'm telling. I think people forget. This is
one is using variance, sir.
I'm using standard deviation, a simple standard deviation. For calculating simple standard deviation.
Mean. We use mean, sir.
We use mean, that we call the actual mean. And another model to calculate is the by using the assumed mean. Okay, this is how the assumed answer. Okay, this is the by calculating this. Now SKP. Karl Pearson coefficient of skewness. How we'll get it? Mean minus mode divided by SD. We know mean, we know mode, by divided by 12, you'll get this. For the discrete series, you go into that, you will understand that there are different formulas. This is when the series is there, f of x, x minus af, df, d square. Then you will apply this formula. This is the formula for SD, and you will calculate mean minus mode divided by SD is equal to skewness of coefficient. Okay, continuous series also will be different. Next, Bowen's coefficient of skewness. See, this also a different formula, but the Karl Pearson one is the very popular one. I'm just skipping this. You just go through the notes and understand how it is. Okay, because different other units also I need to cover. Okay.
So just explain this part only, sir. They have given in the assignment also. We couldn't understand
this one. This one, Bowen's,
yes, sir.
Bowley's coefficient of skewness. I thought Karl Pearson is so important. Whatever. Okay. See, we need to know this again. Let me take back to you here only. See this. Yeah. It is based upon the values of the quartiles and mean. Okay. It is denoted with SKB, SKP, KP, SK, skewness. Okay, coefficient of skewness. P denotes the Pearson. P denotes the Bowley's. Okay, SKB. Okay, now this is the formula. Q3 plus Q1 minus 2 into median divided by Q3 minus Q1. Quartiles, we need to take the odd quartiles, Q3 and Q1. Now let's take this course. Karl Pearson is done. Now Boyle's, let's go into that. Now, how to calculate the Q1? Size of n plus 1 divided by the fourth item. N, we know that number of items is 10 plus 1 divided by the fourth item. Okay, we need to write this in a ascending order. Remember that first thing. If for average, you don't need to write in this. For median, when you're calculating median and mode and other things, better to you need to keep it in the ascending order. Size of n plus 1 divided by the fourth item. See, fourth item is equal to 2.75 item. That is second term. The second term plus 0.75. The third item minus second term. 20 plus 0.75 into the third term minus 2 term. Third time minus 2 term. 42 minus 20. You will get this value Q1 calculated. Next, Q3. Say, general Q1 is size of n plus 1 divided by fourth item. Remember that. Q3 is size of 3 into. Here, because Q1, this is 1 into n plus 1. Because this is Q3, this is 3 into n plus 1 divided by the fourth item. Okay, now size of 3 into n is 10. 1 divided by the fourth item is 48. That is this. Yeah. Divided by the fourth item. Then you will get this value. 3 into this value. And 2.5th item. 2.5th item means 8th term plus 0.25. 9th term minus 8th term. Okay, 0.25, 9th time minus 8th term. You can minus this, then you will get the value 80 minus 7, 870 plus 0.25 into 9th term minus 8th term. You will get this value. Okay. Then, the median size of n plus 1 divided by second item, median. When these values are given like this, size of n plus 1 divided by the second item, size of 10 plus 1 divided by second item, that is equal to 5.5th item, that is 5 plus 6th item divided by 2, then you will get this. Now, SKB denotes what? Skewness based on, what is his name? Bowley's. How you will get this? Yeah, Q3 plus Q1 minus 2 into median divided by Q3 minus 4. Then you will get the value. Simple. So the only thing is that by adding the formula. How you will get the size of Q1? Size of n plus 1 divided by fourth item. Because n is number of items. Fourth item, you will get it. Once you get the fourth item, 2.7th item you need to write. How you will write 2.7th item? Second term plus 0.7th term. Third term minus 2 term. Okay. And this one, you will get it. Here, same thing, 2.75th item, that is 8.5th item. That means 8th term plus 0.25 means 9 minus 8th term. Divide into this one, 8 into 9. Then you will get the simple values. Substitute in this formula. You need to definitely by heart this. What is SKK formula? Given by Pearson. Skewness by Pearson.
3 times mean minus mode by standard deviations.
Super. 3 into mean minus mode by ST. That is the thing. Okay. This is the formula for the Bowles. And if the series is different, discrete is given again, frequency, formulated frequency, from that size into n plus 1 by fourth item, you will get it. Say finding the quartile, I think you learned in the 6th or 7th unit. Once you go back, is it easy to find out that? For continuous series, how to do that also, they have given the same thing. Q1, Q3, you need to find out. Based on that, you need to put that equation in this particular formula, this one. You need to by heart this Q3 plus Q1 minus 2 into median divided by Q3 minus Q1. So simple. Okay, with this we completed this unit and just go through these answers are given. You try it and you will get it. Now we are going into the another part called correlation analysis, regression analysis, and time series analysis. This is also a bit tough thing to understand. But these 3 units we'll try to complete as soon as possible. At least one example if I take, then we can understand it. See this, when we will go with the SEMA, all these analysis part, all these different models are based on the type of data that we are using. Remember that. Because the variables based on the type of variables, how many variables we will take, how the variables are. See, variables means again like this. If you're taking name, gender, or etc. Like you're taking marks, you're taking weights, you're taking that, you're taking this, that, this. If only single variable, only marks is there, then that's fine. Easily you can tell all these things till now what you have calculated. And if you're taking 2 subject marks, or if you're taking 2 variables and comparing, correlation. Let us say your online classes and results. Your online classes and the results. How many classes you are attending? How many marks you are getting? Right? Correlation. But if I'm thinking about only the marks, the above things will be done. See, how many variables are there when we are calculating SD and coefficient and other things, skewness and this? Hello? 1 variable. Please, one variable. If more variables are there when you are comparing, definitely you have to come to the correlation analysis. Explain and define correlation. Express this is a thing introduction. Let's understand this. And why I'm taking some time for you to understand is that if you understand the concept, then if you by heart the formula also, you will have the feel of sense like, okay, I'm not doing as per this because already proved this is how the logic is. Unless you know the logic behind the formula and why we are doing this, see, like let us say for the coefficient of variation, called Pearson or Bowell's, formulas will be different. But how the formulas came, if you understand at least the basic concept, it will be easy. Now let's see. In the statistical method, the methods of central tendency, measures of variation. Till now we have learned this. Measures of central tendency, mean, median, mode. Measures of variation, the coefficient of variation and other things in the previous units are used to analyze the data involving only one variable. But there are some problems involving two or more variables. Correlation in one which studies the relationship between two or more variables, variables. The degree of relation between variables under consideration is measured by the use of correlation technique. For example, family income and expenditure. How much income you are getting, how much expenditure. Yield of a crop and quality of fertilizers used. The more the quality of fertilizer is used, are you getting good crop output? Or if you are using less fertilizer, whether you're going to compare sales revenue and expenditure. How much expenditure you put in, how much revenue you got it. Heights and weights of persons. Is there any relation between height and weight? I am 72 kgs. My height is 5.4 something, 5.5 something like. Is there any relationship then? For whom this kind of analysis will be used? Who will do this? Heights and weights. Hello? Okay, people are not talking, sleepy or eating, I don't know. With the help of correlation technique, we can measure the direction of degree of correlation on figure, which is known as the correlation. This is synthesis. With the help of correlation technique, we can measure the direction and the degree of correlation. How it is correlating direction, how degree and how much more degree it is correlation in one figure, which is known as the correlation coefficient. The relationship between two or more variables is considered as the correlation. If a change in one variable causes the change in another, then it is said that both the variables are interrelated or correlated. There is a lot of correlation is there. That means what I am telling, both are more interlinked. Let us say, technique used to analyze the strength, magnitude, and direction of the relationship between two quantitative variables. Here, this is important. For the quantitative variables, we will use this. Correlation is analysis of covariation between two or variables. Please learn this simple definition given by 30. Okay, I'm not going into the different. What is coefficient of correlation? Indicates the strength and direction of the statistical relation between two variables. The strength is the relationship determined by the closeness of the points. How close they are, my weight and my height. Oh, there is one. Direction is determined whether one variable generally increases or decreases when other variable decreases. See, this is important. Strength, you will understand how strong or how close the both points are, my height and weight. And now the direction. Well, how direction will tell us about? Can you give me that example with the same height and weight? Are you all there? Sunita, Punapa Reddy. People stopped answering.
Yes, sir. So direction, it can show how far it is. Like it is big or small comparatively. It's like if we take a graph, by seeing the direction, we can identify whether it is increasing or decreasing. In such a way, we can. It will be helpful, sir.
Very good. Good, Sunita. See, let us say now I'm taking weight and height. The more the weight the person is, the more the height is. If I come to the conclusion, that means what? The people who are more weight should be more, should be tall. Let us say, if the weight is increasing, the tallness, the size of the tall or the height is increasing. If this relationship is there, what we call the direction is increasing or decreasing. Let us say sales and revenue. The more the sales are there, the more the revenue will. If the more the revenue will be because the sales are increasing. The more you use the fertilizers, the more the output of tomatoes growing in your field. So that is direction. Here, what is strength? The closeness, the points of the closeness. The straight line when pair of values of two variables are plotted on a graph. There are two lines. If both the lines are going in the same way, closed, strength. One is increasing, along with that, another is also increasing direction. Now, properties of the correlation. Correlation is the statistical method to know the relation between variables. Correlation, both variables should be quantitative and related to understand this. You take an example that we cannot calculate income and residents residing in city because there is no relation between two. This is very important. When there is some relation only, we can correlate both the values. Next, correlation is used to measure covariance, but it does not mean that it is necessary shows citations. It means that sometimes both the variables are being affected by the third factor as well. I cannot, always compare both the things. There will be some third factor. Example, weight and height. These are other factors. You may be weight is increasing. It is not because you are tall, your weight is because you are eating more. That is why weight is increasing. Okay, and the correlation coefficient is a numerical way to quantify the relationship between two variables, x and y. It is denoted by the symbol R. The correlation coefficient is always between -1 to +1. Thus, -1 R1. If the correlation coefficient R is positive and there is an increase of x would result in the increase of y. See, if you calculate the correlation of coefficient, which is denoted by the small r. If small r is positive, that means x is dependent on y. When you increase the x, y also will increase. When we decrease the x, y also will decrease. However, r was negative, an increase of x would result in the decrease of y. Now, if r is negative value, if height is increasing, your weight is coming down. Are you getting? Are you all here?
Yes, sir.
Wonderful. However, if r is negative, this is the thing. Larger coefficients at a 0.8 would suggest a strong relation between the larger correlation coefficients. If you are getting big number, 0.8 would suggest a very strong relationship between the variables. Figures like 0.3 would suggest weaker ones. Right? If you get the answer at 0.8, oh, there is a very good strong relation between both of them. Now, coefficient of correlation possesses the property of symmetry. The degree of relationship between two variables is symmetric. Symmetric means equal. That's what we have seen in the skewness. The coefficient of correlation is independent of change of scale. We know that it's a change of scale. The property reveals that if we divide or multiply all the values of x and y, it will not affect the coefficient of the correlation. Next one, if coefficient of correlation measures linear and survey-linear relationship between x and y, whether it is linear, on the same thing or negative to that linear. Two variables are independent, coefficient of variable correlation between them will be 0. This is the thing. If you calculate coefficient of variation, coefficient of correlation, if you get 0 means what? Come on. There is no relationship at all. You have values of heights. Okay. You have values of weights.
0 means there is no there is no dependency between both terms, sir.
Simple. They are very far away from us. If it is negative, sir. If it is negative, if you are increasing x, y is going down. If it is positive, if it is increasing x, y also increase. Positive.
Yes.
Very simple. 3 things you need to keep it in. Again, this is three things. And fourth one is, if the value is high, strong relationship this. Even if value is less, this will be there. Okay, it will start from 0.8 and 0.3 because 1 is the ideal value, the simple mediator value, and the other things are different. Yeah, sorry. Next one. Okay, please keep these points in your mind. Use and utility of the correlation analysis. How it is. Correlation analysis helps in measuring the extent degree of relation between two variables. It also helps in identify the nature, direction of relation, such as positive and negative. And this, okay, this I think. Next one is the prediction. Also can be used to help make prediction. If two variables having known in the past to correlate, then we can assume that they will continue to correlate in the future also. Prediction also we can tell. Okay, in the past, both height and weight are correlated. That means whether it is positive or negative, whatever. If 0 means nothing to think about it. Whether it is positive or negative, whether it is increasing or decreasing, whatever, if it is correlated, in the future also it will be correlated. That is the assumptions. Okay. And theory verification, many psychological theories make specific predictions about the relative variable. For example, if we predict the parents and children's intelligence are positively related, we can test this prediction by administering IQ tests. Next, correlation with causations. Concepts are often confused. Correlation refers to the things that appear to have some form of consistent relation. That is, one item increasing, decreasing when there are change in the another item. Based on observation, we may make a mistake of assuming that correlation can simply cause causation, that the increase in one item is due to other. The distinction between two is very important. When we see correlation relationship, they may make decision based on what they are seeing. This may work out of well if they are lucky and the correlation continues. But as the one event doesn't actually cause the other, it can lead to a poor decision making. See, if there is no, say, without that also, if something is happening there, we need to think about whether it is not or not. Okay, causation, and that's a different thing. Let's go not word. Now, positive correlation and the negative correlation, both the variables are moving same direction. Same direction means this positive, positive, same direction. If the two variables deviate in the same direction, that is, if the increase or decrease in values of one variable results on an average in a corresponding increase or decrease values of the other variables, could be said to be positive or direct. When positive correlation exists, the values of two variables x and y move in the same direction. That is, when there is an increase or decrease in the x, whatever. Same, a positive correlation need not be if it is increasing only. No, if it is decreasing also, if it is decreasing, that is positive. Okay. And then there is an increase in, and there will be increase, decrease in y also. Some examples are for correlation. Height increases, weight also increases. If family income decreases, expense also decreases. Now, that is positive. Say positive means it is not only talking about positive values. Now, negative correlation is the opposite direction. In the negative correlation, the only values one variable is increasing, the values of the second variable decreasing, decreasing. If someone is increasing, the one variable is decreasing and another variable is increasing, again, there is a negative correlation. For example, when prices are increased, demand decreases, right? And the price of the mobiles are increases, demand to buy the products will decreases. When prices are decreases, demand increases, right? No, this is negative correlation. Linear correlation and non-linear correlation. This is also important. Why we need to learn that? This we will see this, and tomorrow there are different types. Methods of measuring correlation, we will see that. Graphical methods and rank method, and this tomorrow. I mean, tomorrow means in the next week, we will see that. Let's check this quickly and we'll close here. Linear correlation and non-linear correlation. When a ratio of change between the variables is the same, then the amount of change in one variable bear a constant ratio to the amount of change in another, then the correlation is linear. For example, x and y with the following values. Here, the ratio of change between the variables is the same. When the amount of change in one variable is not in a constant ratio to the change in other variable, we say that correlation is non-linear. 1 is there, 2 is there, 3 is there, 6 is there, 5 is there, 7. What is happening here? Doubling is there, right? Hello?
Yes, sir. Yes, double.
Constant ratio is there, 1 by 2. Here also 1 by 2. Here also 1 by 2. Here all divided. This constant ratio is happening. This is linear correlation. Here, see this. Here 10 by 10, 1. 20 by 10, sum 2 by 3. Here 3 by 7, 4 by 9, 5. Here, there is a non-linear relation. The ratio between them is not fixed for all the points. Difference are there. That is called non-linear correlation. Now, simple and partial and multiple correlation. Simple correlation, if there are only two variables under study, the correlation is called the simple. The correlation between price and demand is simple. Partial correlation, many, but we study the relationship between two variables, keeping all other variables constant. It is called partial correlation. Example, the relationship between yield and rainfall at a constant temperature is partial correlation. Okay. Multiple correlation, if there is a dependent variable and number of independent variables. Say dependent and independent variable means it is dependent variable means if one is increasing or decreasing, other will be decreasing. So it will be depend on another variable like weight and height. Say weight and height may not be the same all the time, but I'm using this example from the beginning. Now see this relationship between yield, dependent variable, rainfall, fertilizers, seeds are the independent variable, right? This is dependent because we want this. And these are all which cannot change. Rainfall, it may be there, it may not be there. Fertilizers, it may work or not. Seeds, independence is the multiple correlation. Methods of measuring correlation, graphical methods, mathematical methods. You need to remember this. Graphical methods are scatter diagram model, graphical. Pearson method, rank method, co-current derivation. Scatter diagram method is this perfect positive correlation, perfect negative correlation. We'll just go through this. If any sums are there, we will see in the next class. Okay. Now, is this clear? Some basic things. There are some sums we will see in the.
So yesterday, I have asked about your help from.
Yes,
from
tell me.
Your side for assignments, sir.
Yes, ma'am. How can I help you? Tell me what assignments are there and how can I help you?
Just a minute, sir. I'll share the sheet.
Yeah, I think you can't share the screen, but you tell me, ma, there are some questions they have given. You are not able to answer it? Okay.
Yes, sir. We are unable to do that.
Okay, fine then. See, but you can't share the screen to show me what is the assignment, whatever. You have this material now, whatever this PDF is there. Once go through it, based on the particular models, you do it. Or else, my another simple suggestion is that maybe you can use some other external sources as well, YouTube videos. Okay. Sometimes direct questions will be given in the YouTube. If not, okay, Sunita shared a file. Okay, because say it is.
First question, assignment 1. Just explain the question and how it can be solved, sir. We'll do it from our side. 1B.
Yeah, because see the questions which the syllabus is completed, we can go with that. 1 second, let me share the screen.
First assignment is completely into first block 3 units only, sir. Below 3 units only they have given.
That's good. 1 second. Where is this chart? I think my screen is visible, right? Yes. Same and right. Theory you can get it. If the demand and supply curve of this quantity of small derivation that we bought in the equilibrium. This is from which unit? Can anyone guess if the demand?
That's what we are unable to find out, sir.
Okay, you didn't find this model at all in the first 3 units. I think we discussed now mean median mode. It is very easy.
I started attending online classes last week only, no, sir. So I don't know whether this has been explained by you or not.
That is one. This is second question is also I'm just getting confused because from the beginning I'm teaching equilibrium whether I have covered this or not. Will they mention that from which units they have given this? Mostly till what units we have covered from there only they are giving, right?
Yes.
This one just now we have discussed this. Take the model, apply the formula, you will get it. Mean median mode, easy only, right? Already we have seen this.
Second, third, I can say. First one only, like first B part only. I have it.
First B part, that is what. Even that second part also, where I thought I'm not able to, Once go through the notes, my it is not there. Maybe you can try with the Okay, then I will try. Because see, we have very less time. I have given very, less, should I say, time to complete this. Okay, that's fine. 1 second. Let me download this. How to download? Save as. In another faculty will be rating, right? Sorry. Okay. Right now, I will try to get back maybe in the next week if time is there, because I think in next 2 weeks only I will be teaching, I think so. These 2 weeks, I have a few other different units also to complete, because anyway, these less units, I need to give the overview of all the things. I will try my best. Okay. All right, ma. Bye, everybody. See you in the next
Thank
week.
you, sir.
Okay.